So today I actually worked in the lab again a little bit after a long time, and I remember the trick that I want to share with you for making, if you have to do many dilutions, how to make them faster. For some of you this may be too basic, but hopefully for a few of you this will be helpful. It's something that actually I kind of had to come up with myself. It's not something that I was taught. Okay. And I should say already at this point, what I'm going to show you is only going to be useful in case of dilutions where you don't need to end up with a defined volume. So let's say you dilute something and then from your diluted culture you take a couple of microliters and spot them on an agar plate or something. This is not going to help you if you need to end up with a exact volume afterwards. Okay, so we want to make a dilution. So the typical formula, I will assume now we dilute a culture, so a yeast culture, for example, so we say OD, but you might as well also say the concentration of a chemical. So the typical equation that you might know is OD1 times volume 1 equals OD2 times volume 2. So the 1 is what you already have, what you're going to dilute, and what you're interested in is the V1, the volume that you take out, to then make a new culture of volume 2 with OD2, and OD1 is what you measure. So it means we just solve for V1, and that's obviously OD2 times V2 times divided by OD1, and same idea is obviously, or the form that you may know more is C1 V1 equals C2 V2, so same idea. And where this comes from obviously is the conservation of amount of something, amount of cells or amount of chemicals. So you would have N1 equals N2, so obviously this thing that you take out of your first culture solution is then obviously the same amount that you're going to have in your second one. And obviously you know that C is defined as N divided by V, so amount divided by volume. Okay, and so this is the typical way that you would do that, and this is also the way how I would teach that a new student in the lab. Now, the little trick that I want to share with you, or actually let's go through calculation first. So let's first go to Excel. Let's say these ones here are our ODs that we measured. So all this column, obviously. These ones are these 22 different samples. We decided we want to make a new volume of 1 milliliter, so 1000 microliters, and our new OD is going to be 0.1. So what we do, we apply this formula. So V2 times OD2 divided by OD1. So this is the amount of volume that we have to take. And now we dilute it in something. So I said here V med, so medium or whatever your solvent is. And this is obviously the total volume. V2 is the total volume minus this one. And then we do this for all. And we can take away a couple of those digits, maybe not more. Okay, you see we have two where we had a bit of a problem because our starting OD actually is lower than what we want to arrive at, 3 even. Okay, these kind of things can happen. So in this case, we would have to let the culture grow more, or discard them because they didn't grow well. But in general, for all of those where it works, you then take this amount of solvent or of medium, put it in your tubes, and then you take this amount of your culture and add it to this medium. Now this is quite a bit of work if you have 22 samples, right? So the little trick would be we can maybe first of all get rid of this part, and then we can now say what is our V2? So now maybe let's repeat this line OD1. V1 equals OD2 V2. And now what is V2? So let's repeat OD2 here. What is V2? That's the volume of the medium plus the volume, and I'll just call that V1 again, because that's the one that we're taking. So if we now want to solve for V1, we can say OD1 by OD2 V1, and then we subtract V1. This is V med. Then we take the V1 out of the bracket. So we have OD1 by this 1 equals, again, our medium that we put in the tube. And eventually we'll have V med divided by OD1 by this 1. So how does this help us now? This helps us by that we're saying, okay, we do not have, we do not define the V2 anymore, which is the total volume that we want to have in our tube, but instead we want to define the amount of medium that we initially put in the tube, and then we calculate, okay, how much do we have to add to arrive at the dilution that we want, which has, of course, the advantage that then you can put the same amount of liquid into your tubes, and you don't need to, change between each tube. You still will have obviously an individual value for V1 for all of them, but for V2 you can just put the same amount in the tubes. So if we go over here, and this one was also from before, so we had that as well. Okay, so now we have what we want, so our measurement, the OD that we want to arrive at, and the volume that we put in our tubes beforehand. And so once again, we said medium by OD1 by OD2. Minus 1. Okay, so now this is the amount of volume that you have to add to each of those tubes. And once again, why this is helpful, why this is saving time, because you can use the same amount of solvent or the same amount of culture medium, and you don't need to adjust it for each tube individually. You don't need to reset your pipette every time. And of course here, you also can do that even before you start your OD measurement. You can already prepare that. You have less time where your cells will be just growing compared to the other case where you still have to do that after you have done your OD measurement. I mean, we had here values, okay, where the OD1 was just lower than the one that we want to dilute to. This was a problem before with the classical way of making the dilutions. This is a problem here as well. But in this case, you may have another problem, which there isn't really a very obvious case here. So let's say here our OD was above the 0.1, but let's say it was only slightly above 0.1. So let's say the OD that we measured was 0.11. And then you see that you may have to, for example, take 5 milliliters here. And then if you want to do this dilution in, let's say, a 2 milliliter tube, well, then you have a problem. Or it could also be that that you don't even have this much volume, so you don't have 5 milliliters of your solution that you want to dilute. So what you want to do is obviously choose this value here smartly, so the amount of liquid that you put in your tube ahead of time. again, because unless in the classical case, here the volume that you will end up with varies. In the previous case, in the classical case, that's always the same. So here you may just exceed the amount that you can put in your tube. And yeah, by doing it this way, it may be that you need a lot more volume, which also was not a problem in the classical case, because in the classical case, you know, if your culture is essentially what you want, then essentially you take pure culture without diluting it at all. Here, since we said, okay, we already have a certain volume in our tube, that means we also will have to dilute. We will, by definition, dilute it, and which then means if it's very low to start with, then we have to take a lot of it to make up for the volume that's already in the tube. So how can we select this value here smartly? Let's get rid of everything. Then, yeah, of course I didn't grab everything. Okay, let's try to make an estimate how we select our this one here, our V medium smartly. And we can say, well, what about the situation where our OD1 is just really, really high? So in this case, we will probably have the least problems, what I just mentioned, because you won't take much, so you won't exceed your tube volume, and you will only need very little, meaning you will have enough of it. So let's say OD1 we assume is essentially infinite or close to infinite. So this means what we get here, infinite divided by something, so still infinite, infinite means 1, still infinite. We divide something by infinite, so that means our V1 can be super, super small. But of course, in the end, we want to still end up with something, even so we only take this infinite amount of the culture that we want to dilute. We still then want to have a certain amount of the diluted culture. Meaning, for example, if we say we do want, let's say 200 milliliter then to keep working with, then we should say, okay, let's select V medium equals 200 microliter as our lower boundary for the case that, you know, OD1 is infinite. What you could, of course, also do is to say, okay, I know that the highest value that I will ever observe is like an OD of whatever, 3, for example, and then I plug in this value of OD3, and then I can also in this way determine what is the lower boundary for the amount of medium that I want to take. And so now that you know the minimal volume that you can use for medium, I would also use this minimal volume because, well, this is the point where, you know, it will be least likely that you run into these problems that you have to dilute something that already is at a very low concentration, a concentration close to what you want to dilute to, and that therefore it's not working. So go for this minimum. What we can still do is we can estimate which OD1 this will tolerate now. So for this we will just go and reform our equation. So we bring the V1 here and this one we bring up here. So we will have OD1, OD2 minus 1 equals V medium by 1, and then we bring the 1 over and we multiply by OD2, so OD1 equals V medium by V1 plus 1 and OD2, and then let's just play it for those values that we have here. So for the OD2 we said in our example we want to dilute to 0.1, and medium we said okay, we're choosing 200 microliters. Let's say we do this in a 2 milliliter tube, so this puts a bound on the V1 now, that could be 1.8 milliliters, or we can also say maybe the boundary is due to the amount of culture that we have available. But either way, let's say the bound is 1800 microliters plus 1, and then we have 0.1, and then this here is 1/9, so it would be times 10/9. Okay, and I'm not going to use a calculator to calculate this now, but so you see that, yeah, like the lowest that our OD1 is allowed to be is a certain value above the OD2, so 10/9 above the OD2 of 0.1. Okay, I hope this was helpful. I hope this part about then estimating what amount of diluent you can use, I hope this still made sense. And as I said, this trick can be helpful if you don't need a defined amount after your or a defined volume after your dilution.